Hi, everybody. We are live here at Horage, and welcome to day 2 of SUPERSEDE. And today is the official pre-order day. So this is the day that we are going to be kicking off the first pre-order round. So we have 4 rounds that everybody can look forward to. This one is happening for 72 hours, so it starts today at 2 o'clock, which is Central European time, and it'll continue for the next 3 days until Friday at the same time, 1400 in the afternoon Central European time. So if you missed us yesterday, I'm Landon. This is Andi. Yeah, Andi is the founder and CEO of Horage, and I'm a marketing guy and communications. So if you've been in the forums, I've been chatting with a lot of you about SUPERSEDE, exactly what we're doing on this development journey and creating this GMT watch. And it's been really great to be able to communicate with everybody and have you a part of the development journey. And it's actually just begun.
And it's my birthday today.
Oh, it's Andy's birthday today. And,
I have to say it by myself because otherwise it sounds like somebody else I told to say it.
Yeah. So Andy's birthday today. Happy birthday, Andy.
Yeah, I'm getting old, gray hair.
Good day. Good. Pre-orders are good birthday day.
That would be the nicest presents that some people support us for doing more engineering, doing more mechanical, interesting stuff. And that's why we decided also to be more on live calls and videos. Everything needs some practice. Yeah, that's also true. It's uncut everything here. So I'm sorry, or if something goes wrong, please forgive us. But we want to make it as real as possible, and there's nothing to hide here. So what are we going to talk to about? Obviously about SUPERSEDE. We will also show around a little bit. This time we walk in our facility. Everybody's super busy, yeah. Perhaps for the ones who don't know us, there are some people out there.
Yeah.
Yes. Let me bring up some slides here. You see that already? A nice watch. We will come to that later.
I have a few happy birthdays here too in the chat.
Thank you very much. Thank you very much.
Yeah.
It's work day, So I would like to say something about why I think the people should see that now. Yeah. Oh. Wait a second. That was different before. So, yeah, the people who don't know us, they should know that we are known for some movements. Yeah, we have started with K1 some 12 years ago. Everybody said it's not possible. Oh, okay. That's a wrong slide. But anyhow, so we continued with K2. Based on K2, we're going to make this this product SUPERSEDE, and we have this other one which is called Tourbillon, which we are right now super busy to ship. So that's pretty much our lineup, which means when we promise something about shipping movements, we will usually keep that promise, even if it's not that easy sometimes. So let's move to another slide here. Why do we ask people to get into a pre-order or support us in a specific way? It's basically because we want to cultivate more engineering. We are not just making a watch and then sell it and everything okay. We invest a lot into engineering, and that's what we want to continue to do. And all of that money we actually spend into our team. I think that's basically pretty much it. And we are there to expand our team. We want to have more engineers, more young people join actually the making and the engineering of watches. And that's pretty much, let's say, a good idea for us. There's a little bit of it's always a mix, I would say. There's this beautiful hand drawing. That's where things start usually. That's from Thomas Funder, and then you pack that into engineering, and then you need to add this passion for mechanical objects. And I would say we are a relatively engineering and manufacturing heavy company.
Yeah, definitely.
Some people say it's asset. They have some asset light business. Forget that in watch business. You need machines. You need to make that stuff. You need people to design that things. And if you want to be a real watch company, I think that should be the basis for everything, because it's a mechanical machine at the end of the day. Yeah, I think we shouldn't talk too much about slides and things like this. People probably want to have a look at products or.
Yeah, so we can jump into some of the products, but what Andy was saying is basically we are an engineering team and we do a lot of prototyping. And as you could see at the beginning of the live video there, Andy was showing some exploding rockets, I think.
Yeah, yeah. Shall I bring that up again? I like that.
Yeah.
So right here. So
Yeah.
let's make it big. That is, by the way, a SpaceX rocket. I'm a fan of space travel and electric vehicle stuff. But why do we show that? Because we are having the first prototypes here, and this means you actually need to blow up stuff. Yeah, we don't blow up movements, but we break them, and we need to do that several times in order to make it good. And I think that's what some people probably do not understand sometimes, that you have to really try and test stuff early on in order to make that in the right way. We actually yesterday broke our first sample.
Yeah. We already blew it up.
Because everybody, this one,
Yeah.
it still works, but everybody was turning the crown like crazy and trying things, and so I cannot show all. Yeah,
Everybody, you.
Yeah, I mean, you know, if you touch it softly, it won't get better. So you need to break stuff in order to make it better. And that's what you see on that screen with this beautiful animation. So I get rid of that again now here.
Yeah.
Okay, just a little fun on that side.
Yeah. So as Andy said, he's already blown up the first prototype. It is still working though. It's still...
yeah. I mean, there's a lot of small things now. The first prototypes are the most important ones, because this is the first time when you get from CAD drawing to, I mean, we already had a lot of stuff, otherwise you can't do that, but from a CAD drawing to something which feels something. So you get a feeling for the crown, you get a feeling for how you pull the crown, you get a feeling for how strong the force of the spring needs to be to actually set the GMT hands, positioning, accuracy, and very simple, you know, in the first shot, you will need 3 or 4 times to dial it in. It's always like this. This means so there's a continuous effort to improve constantly, make new parts, test them, destroy them, improve them. That's what we do. And that's why we actually also need roughly a year, I would say, in order to prepare everything and make sure that what we ship doesn't come back. Yeah. Because I don't want watches to come back. So
we have a lot of things to blow up over the next year. Yeah. So why don't we jump into the watch, and we'll, because I already see somebody in the comments here or in the chat had said happy birthday, and they would like to see some of the dial colors.
Yeah.
Andy, we're disconnected here?
We are disconnected.
Yeah.
Are you sure? No, I think we are okay.
Yeah. Mark on the back end, do you still hear us?
Yeah, I think so.
Yes.
Because we hear it here. Okay, just in case. No, that looks okay. Yeah, dial colors. Let me switch into my other operational tool here. We have 3 cameras all together. The black one is right on the table with Jonas right now. So I have an arrangement here.
So when we go out into the other room, we'll look at the black one out there. But Andy's got the Jetstream gray, the Boreal green, and the Transatlantic blue here, and the 12 o'clock white, and we'll show the 2400 black here in a few moments.
Yeah, so probably this perspective. Every camera shows it a little bit different, you know. It's a little bit different. I can lift it here, so you see.
Play around with the light there, you get an idea of how that looks.
I can change into that face here.
So for the first pre-order round, this is basically you'll get all 6 options for the dial colors. It's only in this first round that we're offering all 6 dial colors, because we had the Transatlantic blue which Andi is showing there, the teal blue, and also the 12 o'clock white as the top 3 voted colors. So in this first pre-order round, everybody that takes part gets a chance to order one of all 6 of them. So you have all the options available.
Looks good, huh?
Yeah, it looks really good.
I think this today is better.
Yeah, the lighting setup is. We had some time last night to fine-tune some things.
It's a very soft matte-ish finish, and the indexes are diamond cut on all 4 sides, and they're filled with a lot of superluminova. We can't do a dark shot right now, otherwise you don't see anything anymore.
Yeah.
The calendar has a frame around it, as you can see, and we have a very, I would say it's a very good big size, because the movement is 30 millimeter diameter, so you naturally get a relatively big size of a date, which is good. So we don't need 2 discs. That makes things more simple. On top there's a power reserve indicator here. Yeah, it's a, could we say it's a technical looking dial, I would say.
Yeah.
It's yeah, to a certain degree classic, but technical, and it has a lot of depth because these indexes are relatively high. So let's switch over to that one from this perspective. Changing the camera, that's the gray.
And the gray here is a little bit darker than what it will actually be in the full production. And so we are working on the next prototype version of it there.
You see the difference here? Yeah, it's a gray, definitely. Still, I mean, we have a lot of time. We have 1 year time to fine tune things. And I think that's also the main reason why we want to let people know how we do things and what we change, because that's the fun of it. Yeah. So here you see that.
So we have a 72-hour power reserve indicator.
You see here very nicely also the diamond cut on the hand. It's faceted from 2 sides. That's a very interesting process to make that. Actually, they put the hand on a very big wheel, and then they cut with a knife. The wheel is rotating. It's a huge wheel, like 2 meters diameter. Someone's sitting in front, and then you cut off this diamond face. That's one way of doing it. There are other ways, but I think that's a pretty good, pretty efficient and good way of getting a very clean diamond cut. Yeah. So we are here on the dials.
Yeah.
Shall we move on to?
Let's look at the watch again here, and
the complete one.
The complete,
okay.
Yeah. And have a look on the case back as well.
Stuff a little bit. Do we want to? Oh.
We got something picking up a speaker here.
Take your phone away.
There's nothing on there.
No.
Oh, right. Sorry. We're having live speaker problems here.
Okay. So good. Mark is in the background. The guidance.
Yes. If anybody hears another person in the background, it's Mark. He's helping us out.
We have 3 screens here, lots of lights. I mean, it's like a sun studio or something like this. And with all the screens and cameras, you need someone to help to get things done in the background. Okay, so
one of the things is, I just start off, Andi. Yesterday, some people were asking us. They messaged us after the show. Also in the comments, they're asking about the bezel of SUPERSEDE, and they said, "Why is it black from 0 to 15 minutes on the bezel?" And really, it's just so highly polished on the bezel, and the way the light is hitting it and picking it up, it sometimes casts a shadow onto it, and it makes it look like black, but it is polished 904L stainless steel. Yeah,
we are quite happy with the first.
And it has fingers all over it.
Fingerprints everywhere. We are quite happy with the first results of the sample, but of course we need a little bit more crispy touch of the bezel. That's the next step to improve that. And many small details all over the place. Funny thing is, when you see the product isolated, it's different. So each case without anything inside. Then when you put it together, it's completely different.
Yeah.
So things which you thought, which are probably not yet as good as you want to have them, turn out to be pretty good when you put it together, and reversed. And you see things which you didn't see just on the part. So at the end of the day, you need to put stuff together to see how it really is. Yeah, shall I show a little bit the side of the case?
Yes.
Case diameter is
39.5.
39.5.
And it's very thin at just 9.85 millimeters. So very, very low profile. That's what we're able to do with a micro rotor movement. The K2 caliber, the GMT version here is at 3.6 millimeters. So it's very, very low profile.
I don't use my pink fingerlings.
Yeah.
Yeah, that's you see this cutout where the lux actually, where the screw is being put in. This is, we will have a torque screw there, and then you will get bits, so it's easy to change. Let's look into the back side here. It's a screw case back. We decided to go for that because that's better also for, yeah, even distribution of, let's say, the force into the case back rather than when using isolated screws. And the movement inside here.
Those bridges look great in the light.
Yeah.
Plays across the.
That's, you know it from the computer pictures and CGIs already. This is Côte de Genève straight, and then the squares with this matte finish bottom on the other bridges. And as you see.
Yeah, and do you want to talk a little bit about the rotor as well, and the development going on there?
Yeah, sure. I actually have the empty version also. Yeah.
So we have a couple of questions coming up here as well on the dial side of the watch that we'll get to in just a moment.
Yeah. Have a rotor.
So we have a forum on our website. If you haven't joined in yet, I usually write along with Eric or Andy. We always try to do something at least once a week. Sometimes if we get busy, it might be every 2 weeks. More recently, we've been having a lot more conversation going on there as we get ready for pre-order. And one of the topics that we'll be talking more on as the development of the watch continues and the movement is the rotor material, because if you've gone to the website and you voted, you will have seen an option for either gold-plated tungsten, which this is right now, 22 karat gold rotor, or a mystery material. And really it comes down to what is the best fit from an engineering perspective, from a performance perspective, because it's nice to have a beautiful precious metal, but it needs to perform and have the right oscillating weight to rewind the mainspring, and so that you have a watch that performs well on the wrist and you're not always having to continually manually rewind the watch. And that's what's very important for a micro rotor.
It looks more bright than it is if you look at it like this. I can switch to the camera also.
So he was asking, we had a question here, since we're on the case back right now.
That's how it looks in reality, I would say.
Yeah. So Andy, on the case back,
yeah.
Can you explain the reason for the change on the case back and how it's closing now? Because before we had a tool closure.
Yeah.
Yeah.
You just, I mean, you see, wait, I need to switch back to my, you see that rotational direction.
Mm-hmm.
So with a regular rubber thing, you can actually open and close it. And we choose that because, yeah, you have less problem with screws and after service when someone is losing a screw or whatever.
Things getting scratched.
Yeah, things getting scratched. So, and also from, as I said, from the squeeze on for example, on a seal, that's probably a little bit better to control the squeeze of the seal. It's more easy to seal it in an even and correct way.
Okay.
Yeah.
So can we go back over to the front side? Somebody was asking about the engravings of the numerals, or are they just printed? They are.
No, they are etched.
They're etched.
That's actually an etching process. See if I can show that in a different camera.
And that is actually something we are going to make a little bit deeper. It's difficult to see on the camera because we're on a flat surface, but in what we've seen, we are going to slightly bolden the numerals as well as go a little bit deeper.
You can see it on the 45. Where you see that slightly deeper, adding a little bit more crispiness. That's what the plan is.
Yeah, so we had somebody asking in the comments as well, when are we going to start shipping? As we talked about, we're in this entire year still of development. So the shipping will start in December 2022. And one of the other reasons why we want to ship is because of that material up there, silicone.
Yeah, sure.
Yep.
Yeah, I mean, we people who know us know that we have been experimenting with silicon a lot in many years. And yeah, we want to make sure that when the final patent is expiring on the silicon spring itself, that our watches actually have that technology. And we are happy finally that this technology is open for everybody in future because it will make a better watch. That's a fact. Silicon escapement already no problem. We do that since a long time. I can show you the wafer here also. Then you get an idea of how that stuff in reality looks like. My dirty fingers.
Let's take it back a bit. Oh, on camera.
On camera.
There you go. Let's start there.
And there we go. You see the camera there? That's okay. So you see different rows. There are straight ones, and there are actually some which look like little scorpions.
Yeah.
The scorpions ones are the regular ones with a fork to the rear. The other ones are the ones which we use in the tourbillon. So having said that, why have we been able to make a tourbillon in that short period of time? Because we know how to do that stuff. And with this technology, we can improve significantly on the performance of a regulating system. And when we finally are able to add also the springs to the silicon party, then we will have a very, very good product. I'm 100% sure. And that's why we ship next year, December. That's one reason. I mean, it's not the primary reason, to be honest, because we know how to do that. We need to de-risk the rest of the product. So we need to make sure that everything works very well, that the functions are good, that the haptics, do you call that haptics?
Yeah,
the things you feel, you know, crown, tactical winding, the technical things, how it clicks, how it feels. That's what takes time, because this you need several times to iterate. This stuff we know since 10 years, so we are very well prepared when it comes to this technology. We know how to handle that technology very well. Okay.
Yeah. So I think what we're going to do next is we're just going to head out into the facility. We have a few engineers here today, watchmakers, and Andy is going to give one of his tours of the facility, tell you what we do, open up some boxes and see what we can see. So Mark, I'm just going to go get ready to hop into the other room here. Andy, you want to just talk with everybody here?
Yeah.
While I just get set up here.
A wrist shot. I'll make a wrist shot. You go out and I do the wrist shot.
All right. I just, as we are out there as well, we won't be able to reply to the chat. So as soon as we are done with the factory tour, we'll come back here and we will get into chatting with everybody and catching up from where we left off.
I'm here, so Landon is gone. So just to give you a feeling of how it looks on the wrist, it's a very, very good profile. I have one here with a strap. We'll get back to that later after our tour. So I'm very happy with the way actually it sits on the wrist. Really slim for a watch like that with a GMT below 10 millimeters thickness. A very, very nice first link construction on the case towards bracelet. This is a brushed, this is a polished version. I think the polish is better, to be honest. And you see it's really, my wrist is not super big. It's an 18.5 wrist. So yeah, it has a super tech look with a very technical but classic dial, and that's what I like. And I think many people like that. It's definitely worth everything. Yeah. Think of this similar thing like here. Rubber strap is not yet assembled. Do fitting and testing, and you see the screw here standing out there. So Landon is ready. He's calling me. Landon is calling. Okay, so I'm walking over there, and see you in a minute. Are we changed already? We are already in the different thing, huh? Wait. Coming. Good. So welcome again. Now mobile. I think everybody can hear us. Mark, if you can say it's okay, then just say something.
Okay, I can hear.
I don't
Okay.
hear you. Yeah, I hear you now. Okay, so then everything is okay. Yeah, can you turn around one time? So basically, we have a lot of space, but we will also move soon. And it's a little bit of a mess because we are moving in the next 2 months into a new room just down there. And basically also we don't waste space. A good assembly place is a place where it's very densely packed. This means we're going to bring it back around again. Engineering is, as you see, a lot of screens. Everybody is having 3 screens. Engineering is sitting more or less in where we really make the stuff. Because when something is going wrong, the people instantly can talk to the engineer and say, hey, can we change that? There's a problem. We need to improve this. That can be handled, and so on and so on. When we started to make movements, we focused on engineering because the quality of a product comes from the intellectual capability of making it, of designing it. It's not that you buy a machine and then you are cool and can make a movement. That's not the case. Engineering brain work is the first thing. So that's why we invest in people who can do that. Second thing is a lot of quality control and lab. So in the middle, we do all with measure all and control all the components. We really control every component in every step of its life cycle. This means you get a turning part, and we get it back, then we measure it, we send it to the next supplier. All suppliers are around here, 40 kilometers in the radius around here. Why? Because it's the best place to make it. There's absolutely no need to go to China, even if I'm a fan of China also. And I mean, China is a manufacturing place because they are good, but there's absolutely no need to do movement components outside of that place. All the best suppliers in the world are here, and we buy from the best in the world. And that's why we're here. Third decision was control all the T0 by ourselves. This means every pre-assembly spot or a pre-assembly step where you fit 2 pieces together, you set stones on a bridge or you embed a wheel together with something else, we do here. We build all our tools by ourselves. So the real know-how, that's for example a machine here where we do set the stones on bridges, 100% controlled in force and distance. And if the stone is not in the right place or in the right force, then the machine says, oh, not good, red, change something. Super important, otherwise we don't talk about quality products. Don't do that by hand, it doesn't make sense. So as you see, for every little thing you need a tool because freehand is not what we want. We want to have performance. So let's go to the nice here, nameplates. So that's actually positioning tools where you put the part in, then you have nozzles where you pick up some other parts, and then semi-automatically you assemble the stuff. When a company can do all that by itself, then you know that they will be able to ship a product because they can control their own fate. I think that's super important. And in the middle, yeah, we have torque measurement meters. Here we have high resolution microscoping. It's without this you can't do anything. Then this is just interim positioning because we need to go into our next place. This machine is quite interesting here. You know, here we are matching actually balance wheels with balance springs. Because each spring is different, each balance wheel is different. You don't believe that, but it is like this. And then you need to match that. So you need to measure that. And not many people do that. there's not many companies who really do that. Only the ones who really make movements. So that's a pretty clear indicator that we do that. Yeah, here's some assembly. It's a little bit messy at the moment because everybody is busy working and we are putting movements together and tourbillons need to ship. Then going around there, washing is very important. Amanda is having a close look on the stuff here. So at the end of the day, it's a parts war. I mean, we have 3,500 information steps involved in order to make one movement. This means 3,500 times we need to do something in order to get to one product. One of them wrong, movement doesn't work. So it's a process business in a parts war, I call it. And all parts need to be washed, treated, heat treated, hardened, polished. These are the processes which are probably the most difficult ones because nobody sees them. And this is the stuff we needed a long time to figure out and really we have to get a control of it. Then here we do complete assembly. That's actually the T1 assembly where we put together the complete movements from T0 to T1. Terminage it's called, by the way. My French not good, so. Yeah, and here, someone is working on another one of those dials. Laurent. He was a little bit in a rush yesterday because 1 hour before, I think 1 hour before we got the hands before yesterday's show, and then putting it together, and needless to say, there's probably some issues there. Yeah, that's the black one. Okay, and you see there, this is a typical K1 round transfer assembly plate which we have over there. That's the kind of a semi-automation which we use. Yeah, and here are another K2 movements, just without the rotor. Also preparing for more tests. At the end of the day, the next couple of weeks and months, we will destroy a lot of movements. So probably 50 to 100 is we need to destroy in order to figure out where we are. And yeah.
Regulation?
Regulation, of course. I mean, regulated. There's not much regulated at the moment because we have other things to do. But basically, that's our setup where we test all the watches in all the positions. So these things are turning, and then you can see if it's good or not good, and we need to re-regulate. That's the thing we do before we send watches to post-certification. That's a very time-consuming thing, and I hope down the road when we also can have silicone springs, I don't hope, I know, then we will save a lot of time on that process because it's much more easy to regulate a watch with this technology. Yeah.
Okay.
So
we head back in.
We head back in.
And we see what's going on with Pascal here.
Pascal is already changing stuff after we broke movements yesterday. So that's actually the actuator for adjusting the calendar with the target GMT time, correct?
Exactly. You can change date and the GMT with the second position or first position of the crown. And you go forward or backwards to change either the GMT or the date. The date function correcting wasn't working in the first prototype, so we developed a new part. It's just one part that needs to change.
Yeah, and then simulating it.
Simulate again, and then next production, next prototype.
I mean, the hard part in movements, I think, is springs. Because even if you calculate stuff, you still need to try it then at the end and then figure out how close you are to, we are talking about micronewton meter things. It's nothing. And finding that out is really tricky stuff. That's where you lose time. Yeah, great work, by the way. It's a lot of wheels in there. But it's worth it. Yeah, and the fact that we try to make it also to a certain degree modular for ourselves, so you can choose actually which time needs to be adjusted with which time zone or direction. This makes it more easy for us in future to handle also different variations of GMTs. Some people saw that already on our website or in other communication. So lots and lots of work. I don't know how many parts we have in there.
194.
Huh?
194.
194. So it's a little bit more than a K1 full spec with 174.
So we're going to head back in and into the studio here.
Yeah.
Going to turn off the camera and we'll see you on the inside.
Back here. It works. So good. Do we have any questions here right now?
We'll get to them in just a moment.
Yeah. Okay. So let me bring in some stuff and we have something to look at here while I'm setting up again. Change camera. Oh, autofocus. Coming. Yeah, perfect. Someone said, you mentioned you were aiming for 200-meter water resistance. Is that realistic? Would you be willing to add a few microns of thickness to achieve it? Yeah, I mean, we are trying our best to figure out how we can get close how we get to that level without increasing the thickness. We are not yet sure. In the worst case, probably we need to close the case back or add a little bit because basically the concern of my concern might be from the case back. Lenny is also here. You can come in and have a look.
Right.
Some people know that guy. He is actually doing a lot of work here right now. He is putting all the all the balance wheels together with the springs. He is the guy who knows about the matching, the deep stuff in watchmaking.
The regulation master.
The regulation master.
Yeah.
Yeah, but he's doing everything kind of. Yeah, thanks for your hard work. And as I always said, just keep going.
We do our best.
We do our best.
200 meters we should be good. Water depth rating questions are generally waterproofness, or let's say, I mean, it's a difficult discussion. You don't dive 200 meters deep. You can have a 200 meters water deep depth rated watch, which is not very well waterproof, because perhaps some other things haven't been done very well, like the design of the case. The problem with this is basically the case is getting distorted from the pressure. We know that people don't go 200 meters deep with our watch, but we want to have it an all-terrain watch, which needs to survive a dive. You know,
I used to be a diving instructor.
He's a diving instructor. So.
I know for a fact the kind of. I mean, I used to dive with a lot of people with submariners and everything else, and it was always interesting to know that. I mean, we were just going down, basically 30 meters, maximum. And yeah, the watches all performed really, really, really well, easily, obviously. And so 100 meters is, for a regular recreational divers is more than adequate. But obviously 200 is a nice number, and we want to
reach that.
see that. We want to reach that, and that's a challenge for our engineering team, and one of the challenges we put up for ourselves.
It's basically a lot the shape about the glass. It's not necessarily only the thickness. It's how you do the glass, how actually when the pressure is going into the case back and into the front, how actually the pressure squeezes out towards the metal part of, and how thick this metal ring has to be in order to hold against this pressure being applied from center of the glass. So there's a lot of FEM stuff going on down the road, and figure out the best way and then test it and see where we end up.
Yeah. So we had a couple of questions here. Somebody was asking the lug-to-lug distance. It's 46.29 millimeters. Case is 39.5 millimeters, and case thickness is 9.85 millimeters again. Somebody asked, is it possible to use other third-party strap? Maybe, but
yeah,
this time we have.
We could. I can explain to you a little bit on that. I mean, the biggest challenge on the interface between the interfacing between the case and the strap is the first link. So as you can see here, see it like that. Also fingerprints there.
Move us out of the way a little bit.
Clean it a little bit. Okay. It's a little bit more brighter. Okay. So here you see it's empty. And here you see a first link part. And here you see that first link part missing, like this. So that would mean in order to, in fact, change something or to a standard strap, we would probably have to design a specific first link in order to allow that. I think it should be doable. I like very much how it is done in Korea. Super clean, and this was really challenging to fit that small piece into that case in the right way with that shape. And yeah, it shouldn't be too loose and it shouldn't be too tight in order to assemble. This is typically the small stuff which is hard to make. Yeah.
Somebody's asking if it's sapphire both front and back. Yes, it is sapphire crystal.
Yes. Nothing else in our company.
Yeah, there's no other option.
Yeah.
And somebody had asked yesterday if it's anti-reflective. Yeah, it's both
but we
front
only coat inside.
Yeah.
Only coating inside, because outside for a watch which is intended to be worn in the dirt, you know, I mean, you can take that watch out. It's not a specific watch like a Garmin which you take out for sports, but I'm doing quite a lot of mountain biking. I love snowboarding, and I do not want to have to swap my watches all the time, just because I go for a powder run. It should work there, but it's not specifically, of course, not a professional workout watch. Yeah, that's why we call it all terrain, or all situation, or sports utility watch, or whatever you want to call it. Yeah. It means, in other words, you sometimes do some real sports.
And someone was asking, how many pre-orders would we like to get to call the project a success? It is Andy's birthday, so.
My birthday. Yeah, I mean, at the end, we are known for cost sensitivity. Let's take it like this. I always say cost comes from not knowing. If you don't know how many pre-orders you have, it's getting more expensive. But at the end of the day, the movement parts, the majority can be reused also in other models in future. So for us, it is good to get beyond 1,000 to 1,500 units on the movement side of things for ordering parts. You don't need this minimum quantity on the cases. So, I mean, I'm very happy when we down the road over this period of time, we end up somewhere between 500 and 1,000 pieces. Yeah, then that was a good thing, and it pays the bills. And we can hire more engineers. That's basically what we should do. And yeah, that's, I guess,
more engineers, more watchmakers, more machines.
Yeah, machines. Yeah, that's the next step. Yeah. So we plan to invest into machinery to bring in the thing which we waited for 12 years. I mean, we waited for 12 years to buy machining equipment. We have all the rest of the equipment, as you see, and we are very well equipped for engineering and assembly workshop.
And maybe talk about that. Like, I mean, when our engineers have a drawing, they're actually going into the facility a lot of the times, and we're basically buying time on machines. So we are not having to pay and finance machines.
On some of the parts, we need to wait too long. Like base plates, we have very good partnerships and friends, but basically they also have their own stuff to do, and we cannot always squeeze ourselves into a regular production run. So our people sometimes need to wait too long in order to test a new design, to test a modification of a spring. So if you have a machine beside you, like we did that already in the past, we had a Micro 5 here in our place. Some people saw that on some video, I think. Then you make a drawing and you go over and do it. And then next day, probably you can have the result already. And iteration and blowing things up and testing it is super important for us. If we test faster and improve faster, we can make better and better products. I think that's basically what it is.
Yeah.
because yeah, you can imagine a lot on CAD and CGIs and simulations, but at the end of the day, in the metal the proof is in the metal or in the pudding.
Yeah, proof is in the pudding, yeah, but proof is in the metal in this case. I mean, we jumped around a little bit. We were talking about bracelets. We didn't show the rubber straps today, so maybe we'll show
we can do that.
the rubber straps. And anybody else have any other questions they wanted to ask in the chat? We're here back now, so we can answer any of those. I see the orange seconds hand goes so well on this dial. Thank you. It looks a little bit brighter or lighter on the camera than it is in physical, but it is pretty close. So Andy has 2 blank cases here because we haven't had a chance to build it.
Yeah, we are currently doing fitting. At the end of the day, that's what you call as fitting, trying to find out if the first thing, how close it is to series production already, how does it look, how does the brush come through, how does the polish come through. You see there are 2 different. One is polished and the other one is brushed.
Yeah. Yeah, I see that.
Personally, I think I'm for the polished. My personal taste.
Yeah, but you can choose from either one at pre-order.
Anyhow.
I mean, that was a big debate, and yeah, 70% of the people, over 70% voted for brushed center link, and then we also have the polished one. So it's really personal preference.
Probably make it a little bit brighter, so you can see the blue in a better way.
And apologies again for dust. We are working.
Yeah, it's real. It's not a clinic, you know.
Maybe a little bit too bright there. Yeah, let's bring that down. Bit there. There we go. That's good.
Yeah, rubber strap. I probably can show that a little bit. So that's the first sample. It's a 3D printed sample. Amazing what you can do with 3D printing nowadays already. So you have that hole which actually goes into the first link, and with that first link here, you can see that this one you assemble actually with a screw through.
Yeah, and it'll be a torque screw. We mentioned it yesterday, and we are going to provide
these screws here on the side. This one
are just temporary.
Will be torques because that makes it much more easy for people to disassemble and hold it actually with a slotted screw. Then you slip off and scratch something, and so we decided to. I think it's a Torx 3, a very small one.
Yeah, and you want to maybe mention, somebody just mentioned in the comments here, is there going to be any plans for a quick release mechanism? We've talked about that a lot back and forth inside here.
Quick release on that. Well, sorry, I just hit my camera. Quick release for the straps. We are not there yet, and we also did not start engineering on something like that yet. We decided for a solid screw, which is this one. It's not just a pin type of a capsule pin. It's a real solid screw because we can't do all the things at the same time. In simple words, it's not easy to engineer something like this. You need a long time, and when you decide to go for that, this also means down the road, all your product line more or less need to be adjusted to that, and this needs to be thought through very well. And we don't want to rush on this kind of thing. We always think about it a lot, but at the end of the day, it's not yet the time for us to do that.
Yeah, and we want to make sure that it is secure and it's working very well, and this is what is known, and we're very, very positive about it. So we have the 3 colors here. We have the blue, the black, we also have the gray, but we also have a few other colors at checkout, which will be the purple and also the red strap as well. So there's some really nice color combinations to mix up. Somebody had asked as well if there will be any clasp with the rubber strap. And we've gone with the pin buckle again, just for security. And we'll show that.
Pin buckle with fingerprints, right? That's a nice one. Come a little bit closer. First sample also. We will have some More modifications on the side. So the side will be a little bit slimmer, but we are very happy already with this. I mean, there's a lot of discussion all the time amongst the team. It's fighting for the best shape, and so yeah.
Wants to focus on that.
It's focusing on something else. Yeah, it works already. So yeah. This laser engraving here, it's relatively deep, so it looks good. It's crispy. Yeah. Turn it around again.
All right, so for those of you that are just joining a little bit later now, we'll just look at the dial colors again one last time here and have a quick peek at the movement, and then we'll, Andy's just playing around here with the strap here.
I shouldn't do that. I just wanted to do it like that.
Yeah.
You can see.
Yeah.
A little bit too bright. Oh, no. There's also a security thing, this hole.
So that's it's a lock. It's like a keeper lock.
Yeah, keeper lock, and then that thing locks in here.
Yep.
But dials, you won't have more dials.
Yeah, so we'll bring back some dials.
This is
There we go.
buzzer.
Yeah.
I need to make some advertising now, black magic.
Yeah.
There's a camera here and this board to switch stuff. I like.
We're having fun with it.
We need more cameras. I need more cameras, definitely. Okay, so dials. Do we have the black dial already?
I'll go see if he's done with it. Be right back.
I'll bring it here. So, dials are coming. Magnify that later. Yeah, probably I just bring out this one. Switch on the lights. Now it looks different, as you see. So, but it's pretty realistic, yeah. I think it's quite good. That's the gray. That's green. That green is very nice. Warrior forest, very nice. Yeah. And the indexes are crazy. So nice, tall, and super sharp.
So,
Warrior is forest.
yeah.
It's a Tanne, yeah?
Yeah.
In Deutsch.
Yeah. So I have to
like
be
that.
very careful here because I have a
Okay,
black one that Laurent is just building up right now.
Yeah.
So we're not allowed to touch anything on it, but we can bring it across and we'll put it underneath the camera here. And then we have the black.
Nice.
So what is the industry standard for? FKM is the industry standard on rubber straps.
You know that.
Yeah, they're made very
You did
popular
some
by
serious
Apple.
research, huh?
Hey, we're going to talk a little bit about Apple today.
We need to talk about many things.
Yeah. But we're almost at an hour here now already.
Yeah, we are close to. Yeah, I think that should be good now. And then maybe this one again.
I'll just take that black one back to Laurent.
Yeah.
He's in the midst of watchmaking. What are the advantages of the micro rotor? Is it only space?
I mean, it is space when you use it in the right way because it's a 30 millimeter platform. Yeah, sure. But it also, in our case, allows us to do a different platform. I mean, we call this semi-integrated sandwich. Usually, functions are built on top of a standard movement like ETA or things like that. In this case, we can more deeply integrate, and yeah, it was the right platform for us to work with.
Modularity.
Modularity, yeah, modularity, but for ourselves, modularity for the engineers, so that they can actually more quickly come up with new functionality based on a core plate, which is in fact a micro rotor, and the thickness definitely with 2.9 baseline is pretty low. We didn't go below, because if you go below, there are thinner movements, but it's risky because it can bend, and then you have other problems, and we don't want to have problems. So it's as thin as we think it's safe, and that's where we are with 2.9, then 3.3 with the date calendar disk, and then 3.6 will be the kind of standard of our functional versions of the micro rotor. Yeah, and it's nice. It looks nice. In combination with the escapement technology we have, it performs very well, and you know, the micro rotors got a little bit forgotten when the watch industry was killed by the quartz crisis at the end of the day.
Did it have to do with some of the access to softwares and technologies that are more available now to optimize Q trains and
I mean,
and rewinding efficiency and all
if
that?
there wouldn't be software, cloud software like Onshape, and I mean, we are a completely virtualized company already. We are probably the most digitized company in the Swiss watch industry. We don't have servers anymore. We are working in the cloud. We use cloud cut systems. I hope CAM systems also move in the cloud. We do that already with Fusion 360. Simulation tools will be at disposal for many more people. So we are empowered by software technology nowadays. Otherwise, we couldn't do that, I would say. It was very hard in the past to do that, and there's a reason why only a couple of big companies were capable of doing what we do today. Yeah. And what else did we want to do? I think we
looked at the colors, we looked at the cases.
Yeah.
We'll save some other topics to discuss later on. We have, we're actually in 1 hour, we start the pre-order, so I need to get back and get a few things prepared for that. You'll see the products populate for pre-order in the shop right at 2 o'clock today, or right around 2 o'clock. I can only make things live so many times.
Yeah.
As well, you'll see the different buttons on our shop change, or on our website change to pre-order now. And it's going to be open for the next 3 days. As mentioned, all 6 style colors that we have are available for this first pre-order. You can also choose between brushed or polished center links. And you will also have the option of all the 5 strap colors. Those will continue through all the different pre-order rounds. And of course, it's the best price right now as well at 4,500 Swiss francs, because as we mentioned, we are doing a lot of prototyping. And prototyping means that we need to work out some of these things that we've been very transparent with you on. But we have a year ahead of us. And because the Horage community has been with us through our Tourbillon and all of our other projects, even dating back to early Kickstarters, yeah, we have just enjoyed taking people on this journey. And for Andy and myself, it's a lot of fun to be able to sit down and see the comments coming and
lots of practice
and practice a lot, because we see this way of communicating with the community live like this is
it's a total different way of developing a product. I think that's also for our team is they see that we talk with people who are interested in what we do, and that's very motivating. And before, you know, there was a bunch of resellers in between us and the client, or between the watches and the clients, the people who like that. And this is changing. So that doesn't mean that we want to work with people who have getting connected to us and help us sell our products and promote them. But we want to have basically direct contact with the people who use our stuff, who support us. And yeah, and perhaps that's one of the few good things of this pandemic, that we are all used to screen sharing, video, stuff like that, and and we will do more of that, I think. So shall we blow us out of that?
So yeah, we're gonna end on a high note here. I just want to say thank you to Mark on the back end for organizing this, helping organize the live show for us. He's working in the background, and so thank you, Mark. Thank you to everybody who joined. Thank you to everybody who's going to take part in the pre-order. Andy's already blowing up prototypes, and we're going to go live again tomorrow and the following day. And so join us tomorrow and the following day if you do find some time. And of course, this will be live, or not live anymore, but it'll be left on the site here for you, YouTube to view at any time. So
blowing
thank you.
ourselves out.
All right. Thank you, Mark.
Bye.
We're ready to wrap it up. Thank you very much.
Are we off already?